Hi everyone, today we will discuss friction. So let us start with the conceptual discussion of this friction. So here if you see friction, it is a consequence of molecular interaction. So suppose whenever two objects are in contact, let us say this object of mass m is in contact with this surface. Now, depending on the nature of the surface, if this surface is smooth, then this molecular interaction, it will be less. And if this surface is rough, then molecular interaction, it will be more. And because of that, there will be a frictional force or a resistive force which will start working between the contact of these two surfaces. Here when I say contact of these two surfaces, so you can consider the bottom of this block M as well as this surface, either it is your ground surface or it is suppose your table surface or any other surface. So in that case, so a resistive force arises, and that resistive force in general it is called as the friction or the frictional forces. So it depends on the intermolecular forces. Now when two solid bodies are in contact and exert forces normal to their surfaces in contact, normal to the surfaces in contact. So here you can see this surface is in contact, bottom of this block is in contact with this ground surface or the table surface. Now this block is applying a force in this direction on this surface, and this surface is applying a force on this block in the upward direction. Now here when these forces are normal to the surface in contact, then if the surface is rough, then there will be a chance that the resistive force will start acting, and that resistive force in general it will be termed as your frictional force. So the second is, if the surface are smooth, the point-like areas of contact, if you can say this normal reaction, the normal reaction is acting particularly at a point, it passes through, it is perpendicular to the surface in contact and passes through the center of mass of the objects. Is this clear? So areas of contact decrease in number, reducing the number of cold wells. Cold wells means because of which the resistive forces it arises. So that is just a considered area, and or you can say the contact surface, and because of which that resistive force or the frictional force arises. So if the surfaces are extremely smooth, now either the surface can be rough, it can be smooth, or it can be extremely smooth, very smooth, then in that case the irregularity is less than the range of intermolecular attraction, and because of which the roughness, because of which the frictional force comes into picture. But here the irregularity is less than the range of intermolecular attraction, and the molecules of the two surfaces directly interact with each other. The two surfaces are in contact. Now they directly interact with each other, forming one large cold well over the whole area. Means it becomes a complete one surface. So suppose when two surfaces are in contact, let us say this surface and this surface, then only this surface will try to apply a force on this, or this surface, and the top of this will try to apply a force on bottom of this, or bottom of this surface will try to apply a force on this surface. So when two surfaces are in contact with each other, then only we can expect a resistive force or frictional force. But if these two surfaces get intact with each other, there is no relative movement of this, there is no chance that these two surfaces will behave as two different identity. In that case there is no question of any friction, because those two gets diluted with each other, and that behaves as a single object or a single surface. So in that case there will be no friction. So that is the meaning of this statement here. Okay. Now if any external force act on the system to produce relative motion, now let us say this object is lying over this, and we apply some force on this to pull this object in this direction, or if you apply force here to push this object in this direction or pull this object in this direction, it means the relative motion will start, or there will be the chance that the relative motion, either the motion will start or the tendency to move that will start. These are the two different statements. One is the movement starts, another is the tendency for the motion to start. So here tendency, still it is not moving, it has developed the tendency to move, but it is at rest. So between the two surfaces, an effective force parallel to the surface in contact, in corresponding, as soon as this force is applied, and this object will either start moving or this will develop the tendency to move in the forward direction. So as soon as this happens, a resistive force will develop the tendency to act between these two surfaces, which will be parallel to this. So that will be a resistive force, and from there we get the concept of the frictional force. The relative motion has to tear off the welds. Tear off the welds means initially these two surfaces were in contact and there was no relative motion. When there was no relative motion, it means there was no question of any frictional force. Is this clear? Or the resistive force, because they were just lying. There was no tendency to move, or they were not moving with respect to each other. So the relative motion has to tear off, means now tear off the welds, it means now they will try to separate from each other. They will develop the tendency to move with respect to each other, and it experiences opposition or resistive force. So this resistive force is the frictional force. So here, so I will just narrate it again in a simpler manner. So suppose this frictional force, initially this object was at rest lying over this surface. There is the friction still, whether the object is moving or object is at rest. Friction is always there, because friction is the outcome of roughness of the surface. Now, but that tendency does not arise till the objects are at rest with respect to each other. Now suppose some external force F is applied on this object. Now it will either start moving or it will develop the tendency to move. As soon as it develops the tendency to move, it means one object is now moving with respect to another object, or one object is developing the tendency to move with respect to another object. It means the resistive force parallel to the surface in contact that will develop the tendency to act, and that acts always opposite to the applied external force. So here that tendency will develop. Because of that, one surface will try to separate from the another surface, or try to have the relative motion with respect to another surface. As soon as this tendency happens, that frictional force or the resistive force starts acting. So that resistive force will be termed as the frictional force. Now, so because of this, now how to reduce the friction? So progressive polishing of the two surfaces or smoothing them reduces the frictional forces. Like if we have the polishing of the surface, smoothing of the surface, so obviously the friction will start decreasing initially, but at later stages, if you again try to polish more and more, try to decrease it, then again the tendency of the frictional force or the resistive force, it will start acting. So first it will decrease, but again it will start increasing. Now as far as the frictional force is concerned, there are two types of frictional force. One is termed as the static friction, another is termed as the kinetic friction or the dynamic friction. As the name suggests, static friction, it means this is the frictional force which acts on the object when the objects or surfaces are at rest. Kinetic or dynamic friction, the frictional force which acts during the movement of the objects or movement of the surfaces, or the relative motion of one object with respect to the another object. So friction force acting at that moment, that will be termed as the kinetic or the dynamic friction. Static friction is the frictional force between the two surfaces before the relative motion actually starts. I hope this is clear. And similarly, the kinetic friction is the frictional force when the surfaces in contact are in relative motion. So one acts before the motion or the relative motion starts, another starts acting as soon as the relative motion of one surface with respect to another starts. Now, as far as property of the static friction is concerned, here you can see static friction is self-adjusting force, adjusting both its magnitude as well as direction. Its magnitude is always equal to the external effective force tending to cause the relative motion up to the beginning of the relative motion, and its direction is always opposite to that of the external force. This means here, suppose this object is lying over this surface. Okay. Let us say an external force is applied on this. As soon as the external force is applied, either it will start moving or it will develop the tendency to move. Now see what happens. Suppose as soon as it develops the tendency to move, a frictional force starts acting between these two surfaces, that is the bottom of this block of mass m as well as this ground or the table surface. Just suppose it is F, small f. So here this frictional force starts acting. Here you have this applied external force F. The system is still not moving, it is still at rest, but it has developed the tendency to move. Now I will just take some example just to make you understand. Suppose F is equal to 10 Newton. Let us say F is equal to 10 Newton. The object is not moving. The frictional force is acting. This external force of value 10 Newton has been applied and it is still at rest. That means the frictional force at that point it is equal to 10 Newton, because if you apply summation of force F, it is equal to ma. Summation of force F, it is equal to mass into acceleration, and if object is not moving, then obviously acceleration is 0. It means the summation of force is equal to 0. So here 10 Newton is the applied external force and the object is not moving. So object is not moving because of what? Because of the frictional force here. So it means the frictional force has balanced this applied external force and the object remains at rest. So it means in that case you can say F minus F, it is 0 because the object is at rest. So if this is 10 Newton, so the frictional force you can say it will be 10 Newton. Now increase the value of this F is equal to 10 Newton to 15 Newton, and we observe that still this object is at rest. So it means, and this is what? When the object is at rest, this is your static friction. So applied external force was 10 Newton, so frictional force it is also 10 Newton because system is at rest. Now applied force is suppose 15 Newton, the frictional force will adjust itself because at 15 Newton also we observe that this object is not moving. So when this object is not moving, even if this applied external force is 15 Newton, it means the frictional force has adjusted itself and it has balanced this 15 Newton. So at this moment the frictional force it becomes 15 Newton. Okay. Similarly, suppose you increase it to 20 Newton. Still it is not moving. So if still it is not moving, it means again the frictional force has adjusted itself so that it can stop the object, it can balance the applied external force of that 20 Newton and remains the static position or remains at rest. So in that case the frictional force has become 20 Newton. So now you can see these different observations. So when the applied external force was 10 Newton, frictional force has adjusted accordingly because the system is not moving, so that the frictional force is 10 Newton. We have increased the applied external force to 15 Newton. Still we observe that the system or the object is at rest. It means the frictional force again it has adjusted itself and that becomes what? 15 Newton. So that F minus F it becomes 0, and from there we get small f is equal to 15 Newton. Again suppose applied external force is increased to 20 Newton, still the object is at rest. It means again the frictional force has adjusted itself and that becomes 20 Newton. So because of this we say that the static, now it is still static friction because the system is at rest. So static friction it is self-adjusting. itself, it is adjusting itself depending on the value of this applied external force, but it is able to adjust itself till what? Till the motion starts. Till it is in the static position, it will keep on adjusting, so that the summation of force F, it is equal to 0. So F minus capital F minus small f, it is 0. Capital F, it is the external force, small f will be adjusting itself, and accordingly it will keep on changing the values. Now after a situation, like suppose we can keep on increasing, and we observe that the movement starts when this applied external force is 25 Newton. So as soon as the applied external force is 25 Newton, we observe that the object has just started moving. It has just started moving. It has just begun to start moving, or it develops the tendency to move. It means if it develops the tendency to move and it has just started moving, that means it is the maximum value of the frictional force, this 25 Newton. This 25 Newton, because it has developed the tendency to start moving at that applied external force of 25 Newton, and still it is not moving, it means that is the maximum value of the frictional force. The maximum value of the frictional force. So that maximum value of the frictional force that this surface will have, it is termed as the limiting value of the frictional force, or simply F limiting value of the frictional force. Now beyond this, if I apply 25.000 something, very small increase in that force, the object will start moving. It means as soon as the object starts moving, that limiting value of the static frictional force, or simply the limiting value of that frictional force, has now converted to kinetic friction, because initially it was termed as the static friction till it was under or at rest. As soon as the movement starts beyond that limiting value of the frictional force, the nature of the static friction will also change, and now it will start behaving as the kinetic frictional force. So that's why we say that it is a case of static friction, and static friction, it is self-adjusting force. So if you see the graphical representation of all this, suppose you have this graphical representation. So we are increasing the applied external force, and corresponding to that, the frictional force, yani the static friction, is also adjusting. So if the applied external force was suppose 10 Newton, the static friction was how much? Same as 10 Newton. If applied external force was 15 Newton and the movement has not started, it means the frictional force was also 15 Newton. If we have increased to 20 Newton, it was also 20 Newton. So 10 Newton, suppose applied external force is 10 Newton. So the frictional force is also 10 Newton. So can you see this one? We are increasing the value of the applied external force, but the frictional force is adjusting itself. If it is suppose 10 Newton, it is 10 Newton, 15 Newton, it is 15 Newton. It is increasing. We are increasing the value of the applied external force, and corresponding to that, the frictional force is also increasing, the static friction. So, or it is adjusting itself. So suppose it is 0, so it is 0. It is 5 Newton, it is 5 Newton, 10 Newton, it is 10 Newton, 15, it is 15, 20, it is 20, and so on. After that, what happens? It starts moving. Suppose if the applied external force, it goes as we have taken that example of 25 Newton. So if you apply the 25 Newton, so it means the frictional force will become constant, and it is not adjusting. There is no need to adjust itself, because beyond that 25 Newton, it will start moving, because at 25 Newton, it has developed the tendency to move, and beyond that, it will start moving. So up to here, it is in the static position, or it is in the static frictional force nature, but beyond that, it will change the nature, and it will start behaving as the kinetic friction. So that's why here you can see this is straight line. So this is self-adjusting. So from here to here, it is in the static manner. So it is adjusting itself. After that, the movement starts. So that becomes a case of kinetic friction. So here, that's why this line is parallel to this. So here you can consider this small f, and here that side you can consider capital F. Yani the applied external force and the frictional force. This becomes the limiting value of the frictional force, that is the maximum value of the frictional force which it can attain, and after that it becomes constant. Now it does not adjust itself, then the movement will start, and depending on the limiting value of the frictional force, we will have the value of the acceleration. So F minus F, after this it will not become 0, because now it has changed from static to kinetic. F minus F, it will become mass into acceleration. So keep on increasing the value of the applied external force, the limiting value of the frictional force, that will become constant at that point, and beyond that the effect of capital F, it will be on the acceleration, not on the small f, that is the frictional force, because it is now no more adjusting, or it is no more changing itself. So keep on increasing the value of applied external force. Because of that, the acceleration will increase, and we will have a different kind of movement. So here, that's what here we have, limiting static friction. I hope these things are clear to you. Now see this, the limiting frictional force. The limiting frictional force, if we represent with this small f, or simply F limiting, this is proportional to normal reaction. When we consider this object of mass m lying over this surface, so this surface is in contact. The bottom of this small m is in contact with the top of this surface. Bottom of this, it is in contact with top of this surface. So this object is applying a normal force on this surface, and this is applying normal force on this. So we can consider like this. Suppose that normal reaction between these two, it is n. Now, so the limiting value of the frictional force, it is proportional to the normal reaction between these two surfaces in contact. Now this proportionality is replaced by the constant, and we say it is F limiting, it is equal to mu into N. This mu is termed as the coefficient of friction. Mu in general, it is termed as coefficient of friction. N is the normal reaction, and small f is your frictional force. Now when we say F limiting is the maximum value. And what is that maximum value? We have understood. The maximum value of the frictional force, till it can adjust itself depending on the applied external force. So here F limiting, it is equal to mu into this N. Now if the system is at rest, this mu will be termed as coefficient of static friction. If the system is moving, this mu will be termed as coefficient of kinetic friction. So from this you can see this mu is equal to the limiting value of the frictional force divided by the normal reaction. That you can calculate from here. Mu, it is equal to F upon N. So limiting frictional force divided by the normal force. So that's what we have here. Mu is equal to mu s when it is at rest or in the static position. That will be termed as coefficient of static friction. This is coefficient of kinetic friction. Coefficient of static friction is greater than coefficient of kinetic friction. Coefficient of static friction is greater than coefficient of kinetic friction. Now as far as this lubricants are used to decrease the value of the friction, and that happens just because of the smoothing of the surface. So here you can see viscous liquids introduced between the surfaces of two solids in contact. They reduce frictional force, and because intermolecular forces in liquids are much weaker than those in the solids. Now just see there is another term coming, total limiting. This total limiting reaction. What is this total limiting reaction? Now once we have seen, here you have this object, we have this normal reaction, and we have this frictional force. If it has the tendency to move this side, whether it is moving or not, the tendency to move, because frictional force always opposes the motion. Either it will act opposite to the applied external force, or it will act opposite to the motion. So if this object is having tendency to move, either it is moving or tendency to move. So tendency to move, in that case this F will be static friction. If it is moving, that in that case this F will be kinetic friction. But whether it is static friction or whether it is kinetic friction, friction will always act opposite to the applied external force, or it will always acts opposite to motion of the object. So here it has developed the tendency to move this side, so obviously the frictional force will act in the leftward direction. So here if you see this graph, so limiting friction this side, the normal reaction this side. The resultant of these two perpendicular forces, because this and this will always be perpendicular to each other. So the resultant of these two perpendicular forces, that is normal force and the limiting value of the frictional force, that is called total limiting reaction, resultant of these two. Now the angle, this total limiting reaction that it makes with the normal force, and this angle, if it is suppose lambda, then from that right angle triangle that you can see, 10 lambda, that is equal to the limiting reaction divided by the normal reaction, and that becomes your coefficient of friction. So this mu, it is equal to LF upon LF that we have just seen, and that is equal to 10 lambda. This lambda is also termed as angle of repose. Just now we will see that this lambda is also termed as angle of repose. So from here we can consider, if you compare these two, so lambda is always 10 inverse this mu. So if coefficient of friction is known to us, from there we can calculate the value of angle of repose, and that is lambda. Now what is the significance of that angle of repose? We will just see that. Now see here, as far as the definition of that angle of repose is concerned, let us consider this inclined surface. Over this inclined surface, you have this block of mass m. Okay, you can take a small m. Here it is taken as capital M. So let us make it capital M. So weight of this block is acting in the downward direction, which is always perpendicular to the ground surface. If this angle is suppose alpha, then this component will be mg cos alpha. This will be mg sin alpha. You have this normal reaction perpendicular to this surface. So mg sin alpha, mg cos alpha, the weight mg perpendicular to the ground surface. If it has the tendency to move in the downward direction, obviously the frictional force will act in the upward direction along the plane. So frictional force in the upward direction along the plane, mg sin alpha, because of this mg sin alpha, it will develop the tendency to move in the downward direction. As soon as it develops the tendency to move in the downward direction, frictional force will start acting, and that will along the surface in the upward direction. Now if you consider the free body diagram, we have considered the free body diagram, and if you consider the equation of motion, so from this we can write mg sin alpha, this you can see mg sin alpha minus, let us say the frictional force is F. It is equal to what? In general we can write m into a. Mg sin alpha minus frictional force F, it is equal to m into a. But frictional force in general, it is equal to how much? F, it is equal to mu into this n, where mu is the coefficient of friction. N is equal to how much? Mg cos alpha, because the system is not moving, so normal reaction is able to balance this. So n minus mg cos alpha is equal to 0, such that n is equal to mg cos alpha. So putting the value of n is equal to mg cos alpha, you will get frictional force as mu mg cos alpha. Okay, now you can substitute it here. So mg sin alpha minus mu mg cos alpha, it is equal to mass into acceleration. You can put it as capital L. Okay, so mg sin alpha minus mu mg cos alpha, it is equal to m into a. This m and m, it can be cancelled out. Okay, so now before that, before going to the next step, let us see. Till this value, suppose the system is at rest. Mg sin alpha is acting downward, the frictional force is acting upward, and the system is not moving. It means the object is of that mass m, it is not moving neither in the downward nor in the upward. There is no question of moving in the upward direction because there is no external force which is trying to pull it. So it will always have the tendency to move in the downward direction because of its weight component. So it is at rest. So if it is at rest, it means in that case this coefficient of friction mu, it will be behaving as the coefficient of static friction, that is mu s. So here, and if this is mu s, so we can consider this frictional force F as the limiting value of the frictional force, because up to that maximum value of the frictional force the system is not moving, and if the system is not moving, and it means beyond that, as soon as this alpha, because how it can move, we can't change the value of this mu. Mu depends on the property of the surface. So suddenly we can't change the property of the surface. So you can't change the value of this mu. You can't change the value of this capital M because mass of the object. So we can't change the value of M, we can't change the value of mu, and we want that this object should move. So there is only one situation, or only one, you can say, method that we can consider that the movement of a small movement of this capital M takes place, and that is possible only when we change the value of alpha. So if we change the value of this alpha, that is this angle alpha, what will happen if we can change the value of that alpha? Sin alpha increases as alpha increases, and cos alpha decreases as alpha increases. So it means if you increase the value of this alpha, this cos alpha, it means the value of this up to this limit, up to this value, it was not moving. Now we have suppose change the value of alpha. And change the value of alpha means from this angle of inclination of alpha, beta, gamma, delta, anything, we have changed it to some other value. So it means that cos alpha changes. This will get decreased. Sin alpha changes and it will get increased. It means the value of this, it is increasing. So once the value of this is more than this, it will develop the tendency to move. It means the angle at which, now you can pay attention, angle at which the system starts developing the tendency to move. It starts developing the tendency to move. That will be termed as the angle of repose. That is your angle of repose here. So the angle of repose is the minimum value of angle of inclination at which the system develops the tendency to move. So here suppose at this angle alpha, the system develops the tendency to move. It means mg sin alpha will be greater than this mu mg cos alpha. As soon as it becomes greater than the movement start, until mg sin alpha is equal to mu mg cos alpha, the system will still be at rest, but it will be in the tendency to move. It will be having the tendency that it can just start moving. So it means acceleration still it will be considered as zero because it has not yet started moving. It simply developed the tendency to move. So in that case, at this value of alpha, let us say this mg sin alpha minus mu mg cos alpha, that becomes 0. And these two forces are able to balance each other at this value alpha. As soon as we will have a slight increase in this value of alpha, mg sin alpha will exceed the value of mu mg cos alpha, and the movement will start. So for that angle we will have the equation mg sin alpha dash, that angle is suppose alpha dash, the increased value of that alpha minus mu mg cos alpha dash, that will not be equated to 0, that will be equal to mass into some acceleration A, because the movement has started. Up to this alpha it has not yet moved, so that's why it is equal to 0. Now from here if you equate it, you will get mg sin alpha, it is equal to mu mg cos alpha. dividing both the side by this mg cos alpha, mg will get cancelled, and you will get sin alpha upon this cos alpha, it is equal to mu. And sin alpha upon cos alpha, that becomes tan alpha, so that you will have tan alpha is equal to this mu. Mg sin alpha, that was your component of this weight along this incline. Mg cos alpha was normal component, normal in the sense perpendicular to the inclined surface, and n is obviously the normal reaction. So from here you will get mu is equal to this limiting value of the frictional force, because mu mg cos alpha is what? The limiting value of the frictional force. After that the system will start moving. So limiting value of the frictional force and the normal reaction. So from here we get the value of this tan alpha, because sin alpha upon cos alpha is tan alpha. So we have tan alpha is equal to this mu. The system was still at rest, that's why this mu will be termed as coefficient of static friction, not the coefficient of kinetic friction. So mu s, it is equal to Lf upon this Nf, that is equal to tan alpha, and this alpha is termed as angle of repose. So in the previous case when we were discussing that total limiting reaction, there we had introduced that angle between the normal force and the total limiting reaction as lambda. So that lambda, this alpha, as far as the concept is concerned, it is same, or behavior of that it is same. So either you calculate it this way or you calculate that way, you will get the same value or same relation. So mu s is Lf upon Nf, that is tan alpha. From here you can say alpha is equal to tan inverse mu s. So this is also the way to calculate the angle of repose. Once the static coefficient of static friction is known, we can calculate the value of alpha. Sometimes in the problem, coefficient of static frictions are not given, angle of repose value is given. Once the angle of repose is given, from there you can also calculate the coefficient of static friction, so because they are all interrelated. So this way we discuss the frictional force. So it means here, just to summarize this, the entire discussion, you can say the frictional force, it is proportional to normal reaction. From here we get F is equal to mu into N. Mu coefficient of static friction. If it is maximum, that means what? Till the movement start. Before that it will be termed as the static friction. After that it will be termed as kinetic friction. When it is static friction, mu will be termed as coefficient of static friction. When there will be movement, this will be termed as kinetic frictional force, and this mu will be termed as coefficient of kinetic friction. Coefficient of static friction is greater than coefficient of kinetic friction. Now, so from this we can say F limiting, it is equal to mu n. From here we also get the concept of the angle of repose, that we have seen that the angle of repose, if it is suppose alpha, then we get tan alpha, it is equal to coefficient of static friction, because up to this alpha the system is at rest. So that's why here we get coefficient of static friction, not the kinetic friction. So now we will discuss problems based on laws of motion involving the frictional forces also. Thank you.